Hi, in this video we are going to talk about structure pointers, arrays of structures, and passing structures to functions. Let's take a look at this example which demonstrate structure pointers. We have created a structure here, point, and in the main function we have created a variable of the structure. We have initialized x as 10 and y as 20. Then we create a pointer to a structure. Please note that pointer to a structure can be declared in same way as we have been creating pointers for normal variables like int, char, long. We use star operator, and in place of data type we specify the structure name that we have used. And please note that if you are programming in C++, then only it will work. In C you need to use struct also. So we have created a pointer variable that holds address of this variable p, and this is something new with the structures, this arrow operator. When we access structure members using a pointer, we use arrow operator. Please remember, when we were accessing members using a normal variable, like if we want to access something using p, then we use dot, like we have used dot here. But when we access a member using a pointer, we use arrow operator. So this basically accesses x of the object or variable pointed by this pointer ptr. And what is the x value of that particular object? It's 10. So we are going to get 10 on the screen as part of this cout statement. Now we change this x by again using arrow operator. So we access this x using arrow operator, using the pointer, change it to 30, and then we print p.x. So this means you went to that address where this object is stored or variable is stored, and you changed x there. So this x is going to get modified and you are going to get the output as 30. Right? So if you access p.x, if you access p arrow x, you are going to get 30 because they both refer to the same object. Let us now talk about array of structures. We have again the same point structure to demonstrate array. Here we create an array of size 5 where every element of this array is structure type. And you can notice that syntax for creating an array of structures is same as syntax for creating an array of basic data types like int, char, long. So here we create an array of structures of size 5, and this is how we access array members. So if you use simply array I, you will get a particular element of this array, and if you want to access members of that element, you use array I.x. So we run a loop, and inside this loop, we access individual array members using array I, and then we go to those members and change their elements x and y as I and I into 10. And now we print these array elements one by one, and for every element we print its x value and y value. So this is what we get as an output. We get 0, 0 for the 0th element, 110 for the 1th element, then 220, then 330, then 440. Because we have assigned I for x and I into 10 for y. Like normal variables, we can also access individual points in an array by using index. So if I assign array 0 to something, I need to assign it to a point, right? Because every array element is a point. So I assign it to p, and then I access p.x and p.y. So this is another way to access array members. I assigned it to a structure variable p. So I'll get the values corresponding to 0th structure, which are 0, 0. And this cout statement, if I add it to this program here, this is going to print 0 and 0 as output. Let us now talk about passing structures as arguments to functions. Here is an example. We have a structure point, then we have a print function that takes a structure variable p as an argument. Please note that this syntax is similar to basic data types. We have point here as the data type, and this data type is the structure name in case of structures. So we pass a structure to it, and this is where we pass point p to it, right? And this P is a copy of this P. Like normal variables, by default, arguments are passed by a value in C and C++. So this is a copy of this point, and when you print P.x and P.y, this prints this P's x and y, right? And if you make any change to P.x and P.y there, these changes would not reflect here. For example, if I make P.x equal to 5, right, and if I print here Cout P.x, I will get 10 only, because this P is a different variable and this P is a different variable. This is just contains a copy of this P. Let us now talk about one important point about passing structures as arguments to functions. Let's understand this point with this example. We have a student structure which has roll number, name, address, age, and section. And some of these members might be really large strings. For example, address might be a large string. And here is a function print that takes a student variable as an argument. So if we pass a student variable to this function, what will happen? A copy of that student variable will be created here, right? This x variable will hold a copy of this. And if your variable is big, like it has so many members and maybe more members, then all these members are going to get copied one by one, which is inefficient, right? It requires extra time for copying these members and extra memory to hold a copy. So if we want to avoid this copy, we should pass structures by references or by pointers. So we can just add a reference here to optimize this code. This code is better. References not only give you this advantage that you do not create a copy, your compiler does not create a copy. Also, you can change the members of the passed student, right? Because this reference is an alias of the same main class variable, right? So if you make any change here, those changes will be reflected in the main class variable student also. If you do not want this function to change this variable, right, you can use const with the references also. That way, this function will not change the variables, but it will still be optimized. That way, this function will not be able to change members and your code will still be optimized because you are passing by reference. Passing by reference is an option. We can also use pointers. We can pass a pointer to a student. We can change this code to accept a pointer and then access the members using arrow operator. This is also optimized because now what happens is a copy is not created of such a large object. So one important thing, we should always prefer to pass structures by reference or by pointer. If we do not want to change these members of the structures, if we want to ensure that this function does not change, we can use const. But if we want this to change, then pointer and references are the only option, and they also give us performance advantages.